experiment number 3. The aim of the experiment is study of VI characteristic of PN junction diode and Zener diode. So there are two types of diode. Diode is a electronic semiconductor device which is made up of two materials, P and N material. So P type material and N type material. So you will learn about the P type and N type in your theory. So they are semiconductor devices. So today we will study the voltage current characteristic of these two components. One is called PN junction diode, which is a normal diode. Another type of diode is also there, that is called Zener diode. So both have different characteristics depending on how they are constructed, how they are fabricated. So the fabrication and the details of it you will do in your theory. So for the experiment point of view, I'm just telling you a little bit. So VI characteristic means voltage current characteristic. That means the x-axis will be voltage, y-axis will be current, and by taking some varying some voltages in the input, you will measure the current and you will plot a graph. You will be plotting a graph. First, you will take the readings and plot a graph, and that will be called as the VI characteristic of PN junction diode and the Zener diode. So both are different component. So first you will do the PN junction diode, and then you will do the Zener diode. And then if you see these are the equipments when you are doing physically in the lab. So these are the things you need. There will be a breadboard, a DC power supply, voltmeter, that is to measure the voltage, because you are plotting a graph between V and I. So for measuring the voltage, you need a voltmeter that will be connected in parallel. We'll see the circuit diagram, and to measure the current, you will need an ammeter. So you need so you have a breadboard that it is a kind of board where you will do the connections physically. These are needed when you do it physically. And then you need a regulated power supply for the input power. And then I told you voltmeter to measure the voltage, ammeter you need for measuring the current, because you are plotting the graph of V and I. So for them you need voltmeter, ammeter, and the diode itself, PN junction diode. It has a code 1N4007, and then you need another diode, that is Zener diode, because two diodes you are plotting the graph. VI characteristic of PN junction diode, VI characteristic of Zener diode. So both these diodes are needed. So that is also part of equipment. And then you need a load resistor across which you will connect the voltmeter to measure the voltage. So resistor of 1 kilo ohm, connecting wire. So these things you need when you do it physically. Here we'll be doing the same things. We'll be fabricating, conducting using the Tinkercad simulator that you have used in the previous experiment also. Drag and drop, and you will connect the circuit. So this is the circuit diagram that you will be connecting using the Tinkercad for the VI characteristic of the PN junction diode. So here you can see the input is a regulated power supply. So this you will in the Tinkercad you will drag and drop and get a power supply here, a 1 kilo ohm resistor here, and in series you will connect a ammeter. You can here, but 0 to 50 milliamperes of range. And then there is a diode here, you can see 1N4007, across which you will be connecting the voltmeter of the range 0 to 10 volt. So all these, so 1, 2, 3, 4, 5. 5 components are there which you are going to drag and drop in the Tinkercad and connected in this way, in this properly in this form, where there will be a resistor here, ammeter connected in series, and a diode placed here in parallel, and a voltmeter also connected across the diode. So this kind of connection you will do, and you will vary the input voltage, measure the variation in current, measure the variation in voltage, and note down the readings of voltage across the diode and current in series with this resistor. And using those readings, you will plot a graph which will be called as voltage current or VI characteristic of PN junction diode. Now, what is the characteristic of this diode, PN junction? So if you see the characteristic of the diode here, this is the kind of graph you will be getting when you are measuring the, taking the readings and plotting it in this graph, x-axis and y-axis. You can see x-axis voltage, y-axis current. This is called as VI characteristic of the PN junction diode. So when you take the correct readings, if your readings are correct, and when you plot them in the form of a graph, you will get a graph something like this. So what is this characteristic showing? That the basic thing about PN junction diode is that when a PN junction diode is connected in forward bias. So when is a diode connected forward bias? If you see here, this is the diode here. So 1N4007, this is the diode. So what is the characteristic of diode? This is PN junction diode. This is called as PN junction. That means this black arrow mark is P and this line is N. So P is the positive. It is consisting of lot many of holes. And here this line that you see, this is the symbol of the diode. This is the arrow mark with a line. This is the symbol of the diode. So this dark arrow that you see, that is the positive P of the diode, and this line that you see, that is the negative or N of the diode. So PN junction diode, this is the symbol. So whenever we connect a positive voltage to the P part of the diode and negative to the N part of the diode, so you can see in the circuit diagram, positive of the regulated power supply is connected to the P part of the diode, that is the dark part of the dark arrow part, and the negative of the power supply is connected to this line, which is the N part of the diode. And when you connect it this way, in this connection, this diode is said to be in the forward biased. So we say that diode is connected in the forward biased. When positive of the power supply is connected to the P part of the diode and the negative of the power supply is connected to the N part of the diode, we say that diode is in the forward biased. So now when the diode is in forward biased, then what are you observing here? When the diode is in forward biased, then the barrier potential, so there is something called barrier potential. So that you will study in detail in your theory. So when you see this is a symbol. When you see the construction of it, there will be a P-type side, N-type side, and in between P and N, there is a potential that is separating them. So that is called as barrier potential. So each PN junction diode has a specific value of barrier potential. For example, you can see in this here, if your diode is made up of silicon as the semiconductor device, semiconductor material, silicon and germanium are the semiconductor materials. If the diode is made up of silicon, then the voltage separating P and N, that barrier potential is about 0.7 volt. And if the PN junction diode is made up of germanium as semiconductor material, then the barrier potential between P and N is 0.3 volt. So when the diode is forward biased, when we connect positive of power supply to the positive P of the diode and negative of power supply to the N of the diode is forward biased. And when the diode is forward biased, it overcomes this barrier potential. So once it is overcoming the barrier potential, we observe from the graph that the current is going to suddenly start to rise. So you can see in this graph, from 0 to knee, there's something called knee voltage. So from 0 to knee voltage, you can see that the current is almost zero, isn't it? Current voltage is there. You have increased from 0 to knee. There is voltage present between 0 to V knee voltage, but the current is almost zero. There is almost no current, very less current, microampere, nanoampere current. So why this is happening? Because when we are applying the power supply to the diode, the power supply from 0 to knee voltage, that amount of voltage from the power supply is not enough to overcome the barrier potential of the PN junction diode. So therefore, there is no current flowing through the PN junction diode. So between 0 to knee voltage, this voltage that we are increasing, there is a power supply, so we have started increasing the voltage, isn't it? Here you see in the diagram. In this is a regulated power supply ranging from 0 to 30 volt. So when we start at 0, when we have a 0 voltage, then 0.1, some 0.13, some 0.12 or something like, suppose it's not here, the PN junction, we're talking about the PN junction here. Suppose the PN junction diode is a silicon diode. Silicon, we have learned that in silicon diode, barrier potential is 0.7. So we have started the experiment. Our first voltage is 0. then it is suppose 0.1, 0.2, 0.3. We'll be increasing the power supply gradually and measure the measure the current. So we find that there is no increase in the current happening. Nothing, no current is flowing. It is almost showing 0 milliampere, 0 milliampere, 0, until we increase the regulate. When we reach the value of the 0.7 or 0.8, then we will see that some current is flowing through the ammeter, because that much amount, once it is reaching 0.7 or 0.8, the input voltage when it reaches 0.7, 0.8, then it is overcoming the barrier potential of the silicon diode, which is 0.7 volt. So therefore, after that you will find, once it has overcome, that means after 0.7 volt of the input, once it has overcome the barrier potential of the silicon PN junction diode, then you will find that the current suddenly starts to rise in its value. When you measure the current in the ammeter, you will find that after this knee voltage, the ammeter is showing lot of increase in the current, even for a small increase in voltage beyond VNE. You can see the graph. The graph is showing that before VNE voltage, before the knee voltage, the current is almost zero. At knee voltage, current is suddenly increasing. And this increase is happening in a very small amount of voltage beyond V knee. That means after V knee, even a small increase after V knee voltage, current is rising sharply. So this is the characteristic of the diode. This is a behavior of the diode, the way diode is constructed. The P type and N type. P type material is having lot many of holes as the charge carrier. N type of material which is present in the PN junction diode has lot many of your negative charge carrier, and all these you will do in details in the theory. And when we forward bias it, that means when we connect positive supply to the P type of the diode and negative of the supply to the N type of diode, diode becomes forward biased, and the holes with the positive supply and the holes which are positive, they repel each other and they cross over the barrier potential, because barrier potential has become very thin. Once you have increased the voltage, input voltage beyond 0.7 volt for silicon diode or 0.3 volt for germanium. So the overcoming, after it overcomes the barrier potential, lot many electronic charges, that is the holes, they cross the other side to the negative side, and therefore the current begins to rise sharply here after this knee voltage. So the knee voltage for the silicon diode would be about 0.7, and for germanium it would be 0.3, because after this knee voltage, once the barrier potential is overcome, the current is rising sharply. So you have to, in the experiment, you basically have to connect the circuit in the way it is there, and measure the voltage, measure the current, and plot the graph, and see at what point, what voltage the current has risen sharply. So that voltage at which the current values have risen sharply, that value will be called as your knee voltage. You will write V knee equal to, according to your readings, V knee that you got is this much. So therefore, this is what you need to do in the experiment. The other thing about this graph is that if you see the graph from 0 to knee voltage, the behavior of this diode is said to be non-linear. Here it near 0. Between 0 to V knee voltage on the x-axis, the behavior of diode is non-linear, whereas once the current is increasing sharply after knee voltage, once we have forward biased and our input voltage has overcome the barrier potential and we got a knee voltage, and after that the current is rising sharply. So here you will find that the graph has become linear. So the diode is behaving in a linear behavior is linear beyond knee voltage, and it is non-linear between 0 to knee voltage. So these are the observations you have to make for this VI characteristic of the diode. Using this circuit, you have to perform the experiment on the Tinkercad. Sir will and ma'am will help you out how to do the connection. Is it clear? PN junction diode, all of you?
Yes, ma'am.
Okay. Now
Yes,
let
ma'am.
now let us discuss the Zener diode. So Zener diode is another type of diode, and the fabrication of the Zener diode is different than the PN junction diode. So what is the characteristic This is also a diode, but the way it is fabricated, the fabrication is different, and which is what is making the characteristic of Zener diode different than the PN junction diode. So, what is the characteristic of Zener diode? The Zener diode characteristic is that it is always connected in the reverse biased. We have just now learned about the PN junction diode. You can see I just now told you that PN junction diode is connected in the forward bias. Positive is connected to the P type, negative is connected to the N type. Diode is connected in the experiment. We measure the current and voltages with voltmeter and ammeter, and we are plotting a graph and finding out the knee voltage, after which the current value is increasing sharply. So that is a behavior of the PN junction diode. In PN junction diode, we are connecting the diode in the forward biased. Whereas in the Zener diode, this is also a type of diode. It is also made up of PN material, but the construction of it is different than the PN junction diode. And in a Zener diode, the Zener diode is always connected in a reverse biased, not in forward biased. So the you can see this is a circuit diagram for VI characteristic of Zener diode. Zener diode is 1N4733A. Here you can see. In similar way, you have everything here. You have a regulated power supply of 0 to 30 volt, 1 kilo ohm resistor, ammeter, a Zener diode whose N type is facing upwards and P type is facing downwards. If you compare the PN junction diode, it was opposite. Here the P type is upwards, N type is downwards, and the positive is connected to P type, negative of the supply is connected to N type. The PN junction diode is connected in forward biased, and the current is rising sharply after it has overcome the barrier potential. We are increasing the supply from 0, and once it becomes 0.70, 0.1, 0.2, 0.3, we'll be increasing the voltage gradually and measuring the current. We find the current is almost 0 until and unless your input voltage is reaching 0.7 volt for silicon diode. If your diode is made up of silicon, 0.7 volt. If diode is made up of germanium, zero point 0.3 volt. So if you have a silicon diode, we keep on increasing 0.1, 0.2, 0.3. Ammeter value is almost zero current. But once the value of input voltage is about 0.7, 0.8, something like that, we will find that ammeters begins to show us current, and the current value after that is increasing sharply. So that will be our knee voltage, and this is how the process is taking place. This is the behavior of the PN junction diode, VI characteristic of diode. In similar way, in the Zener diode, the same connections are there, but the Zener diode is connected in the reverse biased. So here you can see, to connect the Zener diode in reverse bias, positive of the regulated power supply is connected to the N part of the Zener diode, the negative part of Zener diode, and negative of the power supply is connected to the P part of Zener diode, that is positive part of Zener diode. So if you connect positive to the N part and negative to the P part, then the diode is said to be in the reverse biased connection. And Zener diode is always connected in the reverse biased connection to get one of its characteristic. So what is that characteristic? That characteristic is called as voltage regulator. So here you can see something is written, a properly doped diode which has sharp breakdown voltage is called as Zener diode. It is always connected in reverse biased. It has a sharp breakdown voltage called Zener voltage. After Zener voltage, the voltage remains constant with increase in current. So this is the behavior of the Zener diode. Now you see the graph here. What is the sharp breakdown voltage? When you plot the graph for Zener diode, this is the kind of graph you will get for the Zener diode. So this is your x-axis, this is your y-axis. You can see negative x-axis because we are connecting the diode in the reverse bias. So there is a breakdown voltage here. So the reverse voltage, and this is called as reverse current. In the previous graph, you see what is written here in the PN junction diode, VF, x-axis VF. F means forward voltage. IF means forward current. So forward voltage, forward current in case of PN junction diode. The symbol is VF and IF because we have connected the diode in the forward biased. So we are writing VF and IF on the x and y axis. In case of Zener diode, because we are connecting it in the reverse biased, the y axis is called as reverse current, x axis is called as reverse voltage. And since we are connecting Zener diode in the reverse bias, as you can see in the graph, as we are slowly we are increasing the reverse voltage like this, and some small current is there. We can see here you will get small amount of current, and at some value, at some particular value of the voltage, reverse voltage, you will find that the current value suddenly begin to increase. So that voltage is called as breakdown voltage. Breakdown voltage means at this voltage, the junction of the PN junction of the Zener diode has broken down, and therefore the current is rising sharply. So what is that voltage after which the current is rising sharply? That voltage we have to identify, that is called as the breakdown voltage. So this characteristic of Zener diode is very much used practically, because you will see that because after this voltage there will be no change in the voltage of the Zener diode. Means Zener, this breakdown voltage is a constant voltage. There will be no change in this breakdown voltage, and only current is going to rise. So therefore this Zener diode is used in the, it has an important application. It is used as a voltage regulator. So voltage regulator means that it is going to put it in a circuit, it is going to regulate the voltage, means it will keep the voltage constant irrespective of the load current and load voltage. So therefore, even if the load current is changing, the voltage is going to remain constant. So Zener diode, how it is happening, all that you will study in theory. The application of Zener diode is as a voltage regulator, because this breakdown voltage is remaining constant irrespective of the load current and the input voltage. Even if the input voltage is changing or the load current is changing, the breakdown voltage across the Zener diode is remaining constant. So therefore, for Zener diode, this is how you will make the connection. You will connect the Zener diode in the reverse biased like this. You connect it in the reverse bias. The positive of the supply you will connect on the N part of the Zener diode, and negative will be connected on the P part. Diode is reverse biased. Everything else is same as PN junction diode. All the connections, except that you just have to connect the Zener. That means in the Tinkercad also, in the same circuit, you just have to replace PN junction by Zener diode. Just remove the PN junction in the same circuit, isn't it? In the PN junction circuit itself, in this circuit itself, you just remove the PN junction diode and drag and drop the Zener diode and connect it in the reverse bias. Put the upper part, the negative part up, and the positive part down for the Zener diode. Rest everything will be same. And in similar way, measure the voltage across the voltmeter and current across the ammeter for the Zener diode. Take the readings and plot a graph, and you will get a graph something like this. Measure the breakdown voltage, after which the current is rising sharply. This is all you have to do in today's experiment. This is the observation table. All this is given to you. So in the observation table, you can see some input voltage ranges are given. Some you have to measure the output voltage, output current through the ammeter and voltmeter which is present in the circuit. And then similarly for the Zener diode also, output voltage, output current, because you have to plot a graph between V and I. So therefore V and I readings you have to take and plot the graph. Is it clear about today's experiment? PN
Yes,
junction
ma'am.
diode and Zener
Yes,
diode?
ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
yes, ma'am.
Yes, ma'am.
Okay, now I will
Now
ask
we
sir
will
to,
learn theory now.
I,
Practical, na? You have just studied theory.
now you will do the practical, isn't it, on Tinkercad? Sir will
Yes, ma'am.
guide
Yes,
you on.
ma'am.
Okay. Chinmay sir, Revati ma'am,
Yes, ma'am.
हाँ, आई एम स्टॉपिंग द शेयर, आप देखिए बता दीजिए इन लोगों को.
Yes, ma'am.
हम्म.
So, ma'am has explained everything to you. So, this is the characteristics of PN junction diode, forward bias condition. Okay. So, if you look at the graph, what we need first to find out characteristics of graph, first we need the diode. Okay. That second one is we have to observe the voltage across
Yes,
diode,
sir, sir.
and what is the change in current. So first thing we need a power supply, variable power supply,
Sir,
right? Then second we need a voltmeter and we need a ammeter, right? So if you look at this,
Sir,
चिन्मय सर ये लोग कुछ पूछ रहे हैं क्या? व्हाट हैपेंड?
sorry,
sir, can you
bolo.
please speak a bit loudly? I can't hear you actually.
Is my voice is not audible?
Sir, it's
थोड़ा लो आ
becoming
रहा
sir,
है
very.
सर।
slow.
सर
Yes,
थोड़ा
sir,
लो आ रहा
low.
है सर, थोड़ा
Yes,
जोर
sir.
से लो आ रहा है, अच्छा अच्छा, ठीक है रुको। अभी ठीक है या ये बंद निकालना पड़ेगा ये हेडफोन से? अभी ठीक है?
Yes, sir. It's fine.
एक सेकंड
Yes,
रुको,
sir. Now it's okay.
Yes, sir.
एक सेकंड। ठीक है, बंद कर देता हूँ। अभी क्लियर सुनाई दे रहा है?
Yes, sir. Clear है।
Yes, sir.
अच्छा, तो फिर से वो बात बता रहा हूँ। So what we need for this graph, first we need diode, okay? Then we need a voltmeter to see this voltage, we need an ammeter to see this voltage, and mainly we need a variable DC voltage source so that we can vary the input voltage to diode and observe the current accordingly, right? So this is your circuit diagram. Okay, this is the symbol of your PN junction diode. I have told in the first experiment, this side terminal is your cathode, this side is your anode. Okay, or in practical diode, what will be there? A white color band will be there in white or silver color band will be there in cathode side, right? So here this is a regulated power supply, one positive, then it is connected with a resistor, okay, series resistor. Then series resistor's next terminal 2 is connected with positive of the ammeter supply. The negative of the ammeter is connected with anode of the diode. Then cathode is connected with negative of power supply. At last, a voltmeter is added connected parallelly with the diode. Mean positive of the voltmeter is with anode and negative with cathode. Okay. After this, we will vary the input voltage from this regulated power supply and we will observe the voltage across diode and current across the diode circuit. Okay. So by this experiment, we'll verify that what theoretically ma'am has explained to you, whether practically we are getting same results or not. Okay, the knee voltage or turn on voltage of PN junction diode is theoretically 0.7 volt. Okay, so practically we will verify that whether you are getting that answer or not. Okay, so we'll design this circuit in Tinkercad. Acha. One important thing while designing circuit, because all of you listen this carefully, because from next class onwards we won't explain you the connection part. Okay, we'll provide you the circuit. You have to design the circuit in Tinkercad by your own. Okay, so I'm telling how to do that. First, look at the circuit. Suppose this is a regulated power supply. Take regulated power supply in Tinkercad. Okay, see this positive is connected with resistors first end. Resistors next end is connected with positive ammeter. So you have to connect, check and connect this like serially. Okay, don't connect positive power supply, regulated power supply, then directly diode, then बीच में तुम लोग ये दोनों ऐड करोगे. Don't do that. Okay, go stepwise. From one end or positive end, always go stepwise. First component complete, then next step serially, and keep the parallel connections at last. Generally, voltmeter has to be connected in parallel, so always connect voltmeter at last. Okay, so I will
Yes,
tell you
sir.
how to implement this in Tinkercad. Okay, open Tinkercad,
Yes, sir.
create new circuit. No, you will do it later. I'm just telling that you have to open the Tinkercad. Okay, you do it later. No need to do it now. You have to do by your own. Okay, so this is a Tinkercad page. How to do the connection part. So this is a device called breadboard. Okay, three type of breadboard are there: breadboard, normal breadboard, breadboard small, and breadboard mini. I am using the small one. Okay, if you are going for larger circuit, you can take bigger size breadboard. Okay, okay. So first thing, what is the use of this? is you can design any circuit temporarily using this breadboard. Okay, practically it looks exactly same. Okay, you can see there are a number of holes or dots are there in this breadboard, right? So what are this? You can connect a wire or component directly on the breadboard. Inside this hole, there is a connector, a conductor material. Okay. So this is there are two type of line in a breadboard. One is horizontal, one is vertical. You can see these are the horizontal line. If I am keeping this cursor at this point, total entire horizontal slots getting green color. All of you can see this.
Yes, sir.
Yes, sir.
That means inside that hole a metal conductor is there. If I am connecting a 5-volt supply at this point or this point, total 25 slots will be getting 5-volt power supply. Okay, but there is no connection with second one. Okay, and these are horizontal line. You will get to know how what is the use of these things, horizontal line and vertical line. Okay, these are vertical line. In vertical line, 5 slots are internally connected. Okay, but there is no connection with the second one or previous, next one or previous one, right? And there is a gap. You can see this gap. Then another set of vertical lines. Okay, and at last, another two sets of horizontal line. Okay, so remember in horizontal line 25 slots are internally connected, and in vertical line 5 slots are internally connected. In smaller circuit you no need to use of this horizontal line, you need only vertical line. Okay, if we need more than 5 connection at a particular node in a circuit, okay, in that point only this horizontal line will be used. Otherwise we can use this vertical line. Okay, I will show you how to implement this circuit in using this breadboard so that it will be easier to understand.
Sir,
Hmm.
sir, in horizontal it is 30 dots which are internally connected now.
You have counted the slots.
No,
It's
sir, it is
written
written.
written, sir.
Label 1, 2, 3, 4.
Acha, 30. Okay,
Sir,
okay.
where is
Okay.
negative and positive in vertical, sir?
It is marked. It is not a power supply. It's a connector only. Okay. You have to connect power supply or any whatever you need. We will connect it to it. It's a connector only. Okay. This is a horizontal connector. This is a vertical connector. We'll use this to design the circuit. What component do we need? First thing, power supply.
Yes, sir.
Yes, sir.
9 volt.
One sec. One sec. I will. I'll join. Again. I have to attend it. Sorry. Acha. So we need first component is a power supply. Then second resistor, diode. Okay. Then what else we need?
Voltmeter, ammeter.
Voltmeter, ammeter. So we will use multimeter. We'll take two multimeter. One will be used as voltmeter, and second one will be used as ammeter. Right? So this is the total component we need. Component and equipment
Sir,
we
you
need.
have taken the diode or Zener diode?
Diode. Pin junction
Okay, sir.
diode. If you take Zener diode, this one is a Zener diode.
Okay.
Okay. So first I will set this. This is in first I will set this to ammeter range. So this one is my ammeter, and this is in voltmeter range. So this is my voltmeter. Okay. So this resistance is already in 1 kilo ohm range. So no need to set it. Change its value. Power supply initial voltage will I will set to 0. Okay, let it 5. Okay, now I will design the circuit. Acha. The first point is positive of the power supply. If you look at the circuit, positive of the power supply is connected with resistors terminal 1 or any end, right? So we can rotate this resistance position, select and click on R. Okay. So if I connect this point, this resistor at here, okay. So is it right? That means this rest four terminals are connected with this terminal of resistor and this four terminal are connected with this terminal. So positive of the power supply has to be connected with one end of the resistor. Okay. So I will just click here, click, drag, then leave the cursor, फिर again press, bend the wire and connect it here. And you can change the color of the wire using this part. Okay. You can
Yes,
also
sir.
adjust its position. Now my positive of the power supply is connected with resistor or not?
Connected, sir.
Through this breadboard, as these vertical lines are internally connected. Okay, so now you got the use of breadboard. Acha, can I connect this resistor like this?
No, sir.
No, no, sir.
No,
What
sir.
will happen?
No,
Sir,
sir.
no supply, no. Where's the supply
Both
going?
the terminal will get shorted.
Yes, sir.
Can I connect like this?
No, sir.
No, sir.
No.
Why?
Oh,
There is a
I
separator
think
in
yes,
between.
sir.
Only
They can
5
be
slots are
different.
connected
Yes,
and
sir.
here 5
It
slots
can
are
be.
connected. So we can connect like this. Okay.
Yes, sir.
okay, sir.
Mainly this separator is there to connect the ICs. Have you seen the IC?
Yeah, sir, I see.
Yeah. So these are designed for IC. Okay. So I will get back to the previous stage. So it was connected at this. Okay. Now next end of the resistor has to be connected with what? This end. As per the circuit
Ammeter,
diagram, it has to be connected
ammeter, I think.
with positive. We have connected to this, so this part is completed. Next end is connected with positive of the ammeter. That is important. Okay.
Yes, sir.
So follow this circuit stepwise. So this one is a positive of the ammeter. I will connect this to make the internal connection color green. Okay. So this is next end is connected with positive of the ammeter. Then negative of the ammeter is connected with anode of the diode and cathode is connected with negative. So this is a PN junction diode. This one is anode. This one is a cathode. Okay. So I will connect the diode here. Okay.
Sir, can you explain this again, sir? How?
Uh, you have understood up to this connection and this.
Yeah, sir, understood. Yes, sir.
Yes, sir.
Resistors next has to be connected with positive of the ammeter. Negative of the ammeter is connected here to the anode of the diode.
Anode,
Okay.
yes, sir.
Anode and cathode is connected with here negative of the power supply. At
Sir,
last,
it will be in a parallel connection, no, sir? Parallel with,
with what?
like how we will connect in a circuit?
That I am showing. I have not done that. Okay. And parallel connection is a voltmeter is connected parallelly with the diode. Okay. Here you can see the positive with anode, negative with cathode. I will show you how to do that. So listen, this negative has to be connected with, and negative of the ammeter has to be connected with anode of the diode. Okay. So first I connected the diode at breadboard. Okay. I cannot connect like this because my anode and cathode will get shorted as the vertical line is internally connected. Okay. Again, I am repeating, all of you listen this carefully because you are going to design all the circuit on your upcoming experiment on this breadboard and on this Tinkercad. Okay, so this one is a really important. Okay, in next and from next
Sir,
lab onwards, we won't explain the connection part. Huh.
so why we can't connect in like? Can you explain again?
Because vertical line, 5 slots are internally connected, right?
Yes, sir.
So if I will connect diode like this in a vertical line, okay, so my anode and cathode will get shorted,
Yes, sir.
yes or no? Okay, so how the diode will work? The current will go through the conductor first, no? It won't go through the diode. Okay.
Okay, sir.
Sir, hello, sir.
हाँ बोलो.
Sir, then what about the resistor? It is connected in same.
Each I am repeating. Each 5 line are connected in vertical line only. Only 5 slots. There is no connection with the previous and next one. Okay. So how this
Okay,
resistor is getting sorted? These both terminals are this both end of the resistor are in different vertical lines, na? Okay.
yes, sir.
So but can I connect
Understood.
the diode like this? No. Okay. I can connect the diode like this, or I can place the diode horizontally.
Okay, sir.
Okay.
So we can connect
Now,
diode horizontally.
now the anode of the diode has to be connected with negative of the ammeter. Okay. So negative at this point, negative of the point.
Sir, that was a Zener diode or normal diode?
PN junction diode. Again, I am repeating.
PN
All of you listen carefully. I have already told this thing. What you are asking, I have already repeating this thing. This is Zener diode. Okay, and this is PN junction diode.
Okay, sir.
Don't call
Now
it
Sir,
my
Actually,
both are
it was
looking
not
very
same.
same,
That's
na?
why we
That's why
couldn't
we are
connect.
call it
हाँ ये
don't call normal diode. Normal diode थोड़ी ये नाम है उसका. PN junction diode, Zener diode ये नाम है. Name is PN junction diode and Zener diode. There is nothing called normal diode. Normal diode is no name. Okay, PN junction diode and Zener diode. So you should ask like that whether it is PN junction diode or Zener diode. अच्छा, one more thing, यहाँ पे देखो एक white ये है band है ना? How to identify anode and cathode? This white band means this is the cathode part, negative part. Okay,
Yes, ma'am.
are you all seeing a white band or not on the
Yeah, ma'am.
symbol?
Yes, sir.
Yes, ma'am.
Uh, that white band is the cathode. So that is how you have to identify the anode and cathode. White band side is cathode, other side is anode. Okay.
Okay, ma'am.
अच्छा. Now the negative of the ammeter is connected with anode of the diode. Cathode is open. Okay, and see if I take the wire over this slots, it won't get connected. Okay, to get it connected, you have to put the end of the wire on that slot. Okay. Next, cathode of the diode has to be connected with negative of the power supply. So I am connecting a wire. Make it back. Okay. Now, as per the circuit diagram, it is connected.
Yes, sir.
How to check? Follow stepwise. First, go from positive of the power supply, it is connected with the resistor or not. The negative side is connected with ammeters, positive or not. Okay, whether this resistance value is correct or not. The negative of the ammeter has to be connected with anode of the diode. Anode, it is connected with anode. Okay, then cathode is connected with negative of the power supply. Okay, after this it is connected. Now the voltmeter. Voltmeter's positive has to be connected with anode and negative has to be connected with cathode. Right. So I will take a wire from this point, anode of the diode. अभी क्या होगा? Make it red for positive. Okay, and negative has to be connected with you can change its position later. Okay. So now the parallel connection of voltmeter is done. Positive with the anode of the diode and negative with cathode of the diode. Okay. Now we'll verify the circuit. Right now you can write the reading on Excel and plot the graph. Later we'll plot the graph on a graph sheet. Okay. So in this observation table for PN junction diode, okay, this is the input voltage. This is the input voltage in DC power supply. This is the output voltage has to be observed across diode, and this is the output current has to be observed. I will show you some readings. Okay, click on start simulation. Okay, initial it is 5, set it to 0. Okay, now both the voltage and current across diode is 0. Okay, what is the new voltage of the PN junction diode?
0.7.
0.7. That means up to 0.7 volt there won't be any current flow through the diode. Okay, theoretically. Practically it may be 6.6 or 0.65. Okay, and it may be go up to 0.75. Okay, so 0.1 voltage across diode is 0.1 volt but no current. Okay, so 0.2 no current, 0.3, 0.4 still current is 0. Okay, but voltage is increasing. So it's coming according to graph, theoretical graph. Okay, at 0.5 some minor current is there. Okay, in microampere range. At 0.6 it is increasing. At 0.7 again it is increasing. 0.8. Okay, now the voltage drop across that is 0.5. Okay, so go up to 1, 2 volt, 5 volt, and accordingly the voltage at one point, the voltage drop across diode will stop and current will start increasing. And if you follow the graph up to this point there is no current, then slight current is there. At this point there is very little change in voltage but current is increasing, right? So we are getting output as per theoretical characteristics. Okay. So this is the observation table. This is the input voltage you have to take and note down the output voltage and output current across the diode, right? And
Yes,
another
sir.
Yes,
table is there. This is for Zener diode. Okay. If you look at the Zener diode characteristics connection, only one difference is there. This is Zener circuit. Only Zener is connected in reverse direction. Okay, so just stop simulation, remove this. Okay, select and delete. Place this Xenor diode at place of this, but
Reverse
make
the
sure
direction.
that reverse the direction. Okay, and take the input voltage and note down the output voltage and output current. For now, you can note down the values on Excel and plot the graph there. Okay, later
Sir,
while submitting the record, we'll plot the graph in graph sheet.
sir, in the regulated power supply, when you were changing the voltage, there was
Hmm.
showing a current also, 5 ampere. What was that?
That is the
Here,
fixed
yes.
current. No need to change current. Okay. To limit that current, we are adding this resistor. Okay.
Sir, can you please repeat? Sir.
You don't need to change the current because to limit that current, we are adding this resistor here. Okay. So whatever the current
Okay,
there is, no, it won't affect the circuit. Okay.
okay. It
So,
nullifies the power supply current.
huh. but that won't affect the characteristics here. Okay.
Sir, could you please explain how to take the observation part once again?
After doing this connection, okay, click on
Yes, sir.
start simulation, click on this voltage power supply. We can change voltage from here. Okay, set the voltage to 0 initially. Okay, now this is your input voltage, which you can vary from this. Okay, vary means you have to type the voltage directly. Okay, you no need to click and turn this. It won't possible.
Yes, sir.
Okay, it won't be possible to take exact difference. So take 0, then 0.1, just type the voltage here as input voltage and note down this is the voltage across diode and this is the current across it. Okay,
Hmm.
0.1, 0.2, whatever the values are there in observation table, give that value as input and note the corresponding output voltage.
Sir, current will be 0.9.
Sir, what will the current supply in the power supply circuit?
What is the current values?
0.9.
Sir,
No, all of you are getting 0.9.
No,
no,
sir.
sir. On
I'm
my
getting
power supply, I
No,
got
sir, I'm
5,
getting
sir.
5.
5.
Keep it 5. Okay.
Yes, sir. So we'll do on 5 as it is given. Okay, sir.
And after some time, after doing this experiment, both the experiment, you can check if you keep the current one, there is no effect. Because we are
Okay, sir.
not going up to that level of current in this circuit. Okay. So if you reduce
Yes,
the
sir.
current, it won't affect. Okay, so all of you design the circuit. Okay. The PN and Zener, it should be hardly over within 10-15 minutes. If anyone having any doubt, please feel free to ask. Okay.
Sir, we have to take screenshot of this and attach in experiment. And also graph of
Graph.
Excel. Or you have to write it and or you have to make it
You
and
have to draw
submit.
the graph. You have to draw the graph. For now, you can show the graph. Either you can draw the graph now also, or you can show the graph in Excel. For now, but for record submitting, you have to draw the graph in graph sheet. Okay. So all of you complete the experiment. Okay.
Yes, sir.
And after some time, we'll ask you to share your screen. Okay. Exactly, ma'am.
चिन्मय सर
Yes, ma'am.
ये 4-5 स्टूडेंट्स न्यूली एडेड है हम लोग के लिस्ट में ये BB17 में आपके पास है ना नया लिस्ट
हाँ हाँ मैं तो अपडेट कर दिया था मैम लास्ट लैब में
कर दिए थे
हाँ 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 कर दिया था
ये लोग जो नए आए हैं वो तो फर्स्ट 2 एक्सपेरिमेंट्स किए हैं कि नहीं ना इनको कब कराएंगे डिफॉल्टर में
इनका सेकंड एक्सपेरिमेंट हुआ था फर्स्ट एक्सपेरिमेंट तुम लोग किए थे जो लोग बाद में लास्ट लैब में ज्वाइन किए नहीं हुआ था मैम को लोग नहीं किए थे
नहीं कुछ का आज ही होगा फर्स्ट लैब ये कोई 806 यू हैव जॉइन टुडे ना
अच्छा आज
Yes,
कोई ज्वाइन किया हो नहीं हो
sir, I have joined in the last class too, but not in the first class.
ओके ओके तो तुम लोग का अपडेट हो गया है आज कोई ज्वाइन किया हो क्या
और इन लोग लास्ट क्लास ज्वाइन किए थे
हाँ मैम हाँ अपडेट हो गया था सीआरओ फंक्शनेटर और कंपोनेंट तो अभी यूज कर रहे हैं तो देख ही लेंगे
हाँ ठीक है फिर लिख देंगे ऑल ऑफ यू शुड राइट द रिकॉर्ड फॉर फर्स्ट एंड सेकंड एक्सपेरिमेंट and submit by Sunday. No, I've given a date and time for Sunday. So those who have joined late, they